A stone is dropped from the top of a cliff. It is seen to hit the ground below after 3.55 seconds. How high is the cliff?
Okay, what do we know here?
We know that the initial velocity would be zero because it's being dropped from a place.
Right?
And we also know that the force of gravity is acting on it, and that would be negative 9.8.
Nice. And we know that the time is 3.55 seconds.
Yeah.
We are looking for delta x, the change in position, or the change in height. If you want to call this delta y, that's also an option. What equation can we use that's going to help us solve for delta y using these other variables?
So we could use delta y equals initial velocity times time plus 1/2 times acceleration times time squared.
Nice. Let's go ahead and fill this in. Delta y, what's the initial velocity?
0.
And the time's 3.55, but I'm not even going to put that because anything times 0 is 0, plus 1/2 times negative 9.8 times 3.55 squared. Can we solve this on our calculators?
We can.
Let's do it. I'm not going to even include the 0 times 3.55 because I don't need to. I'm going to do 1/2 times negative 9.8 times 3.55 squared. Now, if you come up with an error when you're doing that, make sure that there's usually a negative button and a minus button, and those are two different things on your calculator. Matt, what did you get for your answer here?
I got negative 61.75 meters.
This is the distance that the rock falls. Now let's note here, the final, y final is going to be the bottom. It's going to be equal to 0 meters. Y initial is the top. We have delta y equals y final minus y initial. So if we want to get y initial, we just solve like this. Negative 61.75, that's delta y, equals 0 minus y initial. And we get that y initial is 61.75 meters as the initial position. Position versus distance. Similar, but different things.
Pardon me.
Bless you. Awesome. Let's go on to let's go on to part 2, or number 40, I should say. This is a completely different question. It has nothing to do with number 39. Go ahead and read this one, Matt.
Estimate how long it took King Kong to fall straight down from the top of the Empire State Building, 380 meters high, and his velocity just before landing.
Awesome. I tried drawing the Empire State Building and I failed miserably, so I'm drawing a rectangle. So we have that delta y is 380 meters. We want to calculate time and final velocity.
Could we use delta y equals initial velocity times time plus 1/2 of at squared and solve for the missing variable that way?
Let's try it. What is the acceleration going to be equal to?
Negative 9.8.
Perfect. What is the initial velocity equal to?
0 once more.
Perfect, because he's falling, and so he didn't jump down or jump up at the beginning. And we want to find time. Go ahead and plug these in to solve. So we get negative 380 equals 0 times time. That cancels out. Plus 1/2 times negative 9.8 times t, which is what we're solving for, squared. I'm going to do a little bit of algebra. This just goes away. We don't have to worry about it. Negative 380. Multiply both sides by 2 to get rid of that 1/2. And divide both sides by negative 9.8. Not 9.t. 9.8. That's going to be equal to t squared. If we want to solve for just t, we take the square root of all of that. 380 times 2 over 9.8. Notice I got rid of the negatives because a negative over a negative is a positive. If you put this in your calculator, make sure it's all in parentheses inside the square root. Matt, let me know what you got for this answer.
I got 8.8.
Nice. What's the unit?
The unit is 8.8 seconds.
Awesome. That is our time. Now the second part is asking for the velocity just before landing. So we have a second unknown, v final, but now we know our time.
What I think we can do here is we could use v final equals v initial plus acceleration times time now that we've solved for the missing time variable.
I agree. Let's go ahead and use this to solve. V final equals 0 minus 9.8 times 8.8. Let me know what you get.
Would it be negative 86.24 meters per second?
Yeah, awesome. Our final velocity is going to be going down at 86.24 meters per second. Good stuff. Do one of those virtual high fives through the camera.